Hello, Music Theory 1. This is video number 7, Understanding Time Signatures. This is getting close to the end of the review section of our show, but in this one we're going to talk about time signatures, we're going to talk about the rhythmic aspects of music, and some of the basic ways we're going to use to describe rhythmic elements in our music. Before we jump into time signature, we need to know a little bit about the way we're going to talk about rhythm. Rhythm in Western music is sort of stratified between these different levels. And when we start talking about rhythm, we're going to start with what we're going to define as the beat. The beat in music is usually what we feel is sort of a steady, even pulsation. It's what we tend to tap our foot to when we're listening to music, or what we tend to see the conductor conduct in a piece of music. It's what we feel is a very steady level of rhythmic activity. Sometimes we also hear sounds that are much faster than the beat, and we're going to call these beat divisions. These are often too quick for us to tap our foot to or to conduct, but they do go by very, very quickly in music, and so we tend to hear them as well. When we're trying to describe the rhythm of music, how the beat division relates to the beat is one of the important qualities of the music. Another level of rhythmic activity is what we call a measure of music. And a measure goes the other way. A measure is larger than a beat. A measure is a collection of beats. We tend to see these in terms of the pattern a conductor might conduct, and these also help us describe the music that we're listening to. And so when we're talking about rhythm in music, we tend to talk about both how many divisions go into the beats that we are counting, and how many beats go into the measures that we're counting. Let's listen to some quick, simple examples so we have an idea of what's going on here. The first example has a drum that's going to just represent our beat. It's going to be very simple, very plain, and very steady. Let's add some very fast divisions inside of the beat. And then, slower than the beat, we'll articulate the measure with some chords. So there's a quick example of how we can listen to these different levels of rhythm, and we'll spend some time in class going over some more examples in more detail. When we're talking about these rhythms, now we want to start getting into some of the different ways we can classify them. Okay, we want to be able to talk analytically about rhythm in music. And the first quality we're going to look at is how we divide up our beats, and specifically how many divisions fit inside of one beat. We have two ways we can talk about this. We can talk about simple meter. And simple meter means that our beat divides into two equal beat divisions. The alternative is compound meter. Compound meter means that the beat divides into three divisions. Three equal divisions. This is all we're talking about when we describe simple and compound. We're describing whether the beat divides into two divisions or into three divisions. We also have another way we're going to be describing meter. We're going to be describing meter as duple, triple, or quadruple, and this is also based on divisions, but it's based on a different division. It's based on how many beats we can divide our measure into. Simple and compound talk about dividing a beat into divisions. Duple and triple and quadruple talk about dividing a measure into beats. A duple meter means the measure divides into two beats. A triple meter means the measure divides into three beats, and a quadruple meter means the measure divides into 4 beats. And we are going to be combining these. And so we might describe a meter as simple triple. That means the measure divides into 3 beats because it's triple, and each of those 3 beats divide into 2 divisions because it's simple. Or we might describe a meter as compound duple. It would be duple because the measure would divide into 2 beats, and it would be compound because each of those 2 beats would divide into 3 beat divisions. It's very important that we keep these straight. Simple and compound talk about divisions inside of a beat. Duple, triple, quadruple talk about beats inside a measure. Now that we understand our basic categories of time signature, of meter, we can talk about how we're going to write them. Every time signature has 2 numbers involved in it, and you can see a very common time signature, 4-4, right here. Time signatures work differently for simple meters and compound meters, and so let's start with simple meters. In simple meters, the top number tells us how many beats. That's all. And the bottom number tells us what value gets the beat, what rhythmic value. And so when we see 4-4, the top 4 tells us that there are 4 beats in the measure. And the bottom 4 tells us that we're going to represent those beats with quarter notes. If the bottom number was an 8, we would use eighth notes. If the bottom number was a 16, we would use 16th notes to represent the beat. If it was a 2, we would use half notes. Okay, and that covers most of the common ones, though I suppose we could have 32s or 64s if we were feeling adventurous. And so if I wanted to map out this time signature, I would draw those 4 quarter notes first. Because this is a simple meter, I know those quarter notes are going to divide into 2 beat divisions. And so when I'm representing this meter, I know those quarter notes divide equally into 2 eighth notes. And I tend to draw both the beat, the quarter note here, and the division into which we divide it, the 2 eighth notes. Here's a nice diagram of 4-4. We can see the time signature, we can see the beats on top and the divisions on the bottom. The last thing we want to do is identify what kind of meter this is. Well, we know it's simple because each beat divides into 2 beat divisions. To figure out whether or not it's duple, triple, or quadruple, we need to figure out how many beats are in the measure. And we can see that there are 4 beats in this measure. There are 4 quarter note beats. And so this is a simple quadruple time signature. 4-4, simple quadruple. There are 4 beats represented by the quarter notes here, and each beat divides equally into 2 beat division represented by the eighth notes here. Another simple meter might be 3-8. Again, it's a simple meter, and so the top number, the 3, tells us how many beats, and the bottom number, the 8, tells us what rhythmic value we're going to use to represent that beat. Here, we have 3 eighth notes representing the beat, and so you can see I've drawn them on the top portion of my staff, and then I've drawn the division on the bottom portion. Because this is simple, our division is going to be a division of 2. We're going to have 2 equal rhythmic values below each of our beats, and smaller than an eighth note, it's going to be 2 16th notes for 3-8. Here's a nice diagram of 3-8, which is a simple triple meter. There are 3 beats in this measure, and so 3-8, a simple triple time signature. For our simple meters, the top numbers are always going to be 2, 3, and 4. Remember, for simple meter, the top number tells you how many beats. And so if we see a 2 on top, it's always going to be a simple duple time signature. There's always going to be 2 beats that divide into 2s. If we see a 3 on the top, the time signature will always be simple triple. And if we see a 4, the time signature will always be simple quadruple. That summarizes our simple meters pretty well. Let's move on to compound meters. Compound meters work differently than simple meters. The top number does not tell you how many beats are in the measure, and this is a really important distinction. When we look at a compound meter like 6/8, there are not 6 beats in the measure. I'm sorry, there's not. The top number tells you how many beat divisions there are, and the bottom number tells you what beat value gets the division. And so when we look at 6/8, we're being told there are 6 eighth notes that represent the beat divisions in the meter. To group them into beats, well, we know that because it's compound, our beat has 3 divisions inside of it. And so we need to figure out what rhythmic value can hold 3 eighth notes. Here, the answer is a dotted eighth note. A dotted eighth note can hold 3 eighth notes inside it. This is sort of why compound meter works this way. If we were to write this as a simple meter, right, we would sort of have to write, well, 2/4 would mean 2 quarter notes, but what about 2/4 1/2? Right, that's kind of what it is, a quarter note plus of a half of a quarter note, or 2/4 with a dot. The rhythmic notation becomes a little bit complex there, and so even though maybe it would have been worth the complexity, our musical tradition decided to adopt this way of notating compound meters, and so we're stuck with it. One thing to note is that compound meters will always have a dotted value as their beat. Because the beat divides into 3 divisions, we need some sort of dotted value to represent our beat. Let's look at another compound meter. 12/16 is another compound meter, and because it's compound, we know that the top number is telling us how many beat divisions, and the bottom number is telling us what value gets those divisions. And so I see a 12, I know there are 12 beat divisions in this measure, and the 16 tells me that the 16th note gets the beat division. I've drawn my 12/16 notes here, and because it's compound, I'm going to be grouping them in threes, right? Our beat divides into groupings of 3 beat divisions, and so you can see I've beamed my 16th notes into threes. To finish this diagram, I need to figure out what rhythmic value holds 3 16th notes inside of it. What rhythmic value? We know it's got to be a dotted value. All our non-dotted values will divide into 2s. And so it must be some kind of dotted rhythmic value. You may have figured it out. It's a dotted eighth note. A regular eighth note divides into 2 16ths, and the dot adds half as much, which will give us 3 16th notes. 12/8, the beat is the dotted eighth note. The division is those 12 16th notes. You can always tell a compound meter by its top number. A 6 on top will always be compound duple. A 9 on top will always be compound triple, and a 12 on top will always be compound quadruple. Remember, these numbers tell you the number of beat divisions. They do not tell you the number of beats. Okay, compound meters, they work differently from simple meters. That's the end of video 7 on understanding time signatures. We talked a little bit about the way rhythm works in music and the different levels of rhythm that we talk about. The beat, and then faster than that, the beat division, and then slower than that, the measure. We talked about ways to describe time signatures as simple or compound based on how many divisions go into a beat, and as duple, triple, or quadruple based on how many beats go into the measure. And finally, we talked about using time signatures to help represent these rhythms, talked about the different ways simple and compound time signatures are represented with numbers. Okay, this is an important one to make sure we understand the rhythmic structures of music. Thank you for watching with me, guys. Hope you enjoyed it, and I will see you next time back in class.